Graph. How to graph linear equations. What is it? A diagram of values usually shown as lines. Why? Helps in analyzing data. Interesting fact, around 40% of all known insect species are beetles. This equals about 400,000 species. Some estimates suggest that there could be as many as 3 to 8 million beetle species on Earth. Here are the 4 examples we're going to be talking about in today's video. Let's take a closer look at example 1. Let's read the steps. Step 1, pick several inputs. Step 2, find the outputs. Step 3, plot the points and connect the dots. Let's read the question. Graph the given equation y is equal to 2x plus 3. Now you may be wondering, what inputs or values of x should we choose? It's up to you. You can choose any, but we are going to choose -1, 0, and 1. Why are we picking those integers? Because they are the smallest integers possible. -1 is the smallest negative integer, 1 is the smallest positive integer, and 0 is in between those two numbers. And 0 is a special number when we're talking about equations. So let's go ahead and get started. Let's write down the equation. Y is equal to 2x plus 3. We can go ahead and substitute the value of -1 into the equation. Now we have 2 times -1 plus 3. 2 times -1 is -2. Now we have -2 plus 3, and the result of that is 1. So our output, or our value of y, is 1, and we put it into the table, and now our point is -1, 1. We're going to go ahead and graph that, and now we move on to the next input. In this case, it is 0, so we substitute 0 into the equation. Now we have 2 times 0 plus 3. 2 times 0 is 0. Now we have 0 plus 3, and the result of that is 3. So we plug that into the table, and now we graph the point 0, 3. Now let's take a look at the last input. Substitute 1 into the equation. Now we have 2 times 1 plus 3. And 2 times 1 is 2. Now we have 2 plus 3, and the result of that is 5. So we have our last coordinate point, and we're going to go ahead and plot that onto the graph, and we have 1, 5 as our last point. Now once again, why did we pick 3? Because sometimes you make a mistake when you have 2, and you don't realize that you made a mistake because you only graphed 2. And if you graph 3, like we're doing now, we got rid of the work so we can focus on to the graph, and we graph the line, and it goes through all 3 points, then you know you did it correctly. So we have graphed y equals 2x plus 3. Now let's take a look at example 2, and we have the equation y is equal to -3x minus 2. We're going to use the same input values for the same reasons as for example 1. Now let's go ahead and get started. Now we're going to substitute -1 into the equation, where we have -3 times -1 minus 2. And -3 times -1 is 3, because when you multiply two negative numbers, it becomes a positive. And now we have 3 minus 2, and the result of that is 1. So, and we plug that 1 into the table, and we plot the point -1, 1. And now we're going to focus on the next input, which is 0, and we substitute that in. Now we have -3 times 0 minus 2, and -3 times 0 is 0. And now we have 0 minus 2, and the result of that is -2. Plug that into the table, graph the point 0, -2, and now we have 2 dots, or 2 points on the graph. So let's take a look at the last input. We're going to go ahead and substitute 1 into the equation. Now we have -3 times 1 minus 2, and -3 times 1 is -3. And now we have -3 minus 2, and the result of that is -5. So now we have our last point, 1, -5. Plot our point, get rid of our work so we can focus on to the graph. We have three points, so our line, if we did it correctly, should go through all 3 points, and it does. And that is the equation for y is equal to -3x minus 2. Now let's take a look at the example 3 with the equation y is equal to 1/2 x minus 4. This time our inputs are not going to be the same. And why are they going to be different? Well, we have a fraction in front of the variable x. And since we don't want fractions in our answer, because if you look at the graph, there are no decimals, there's no fractions. It's a little bit harder to graph when you're dealing with that. So we're going to pick numbers that are multiples of 2, so that when you multiply the 1/2 times the input, you get a result of you get an integer as a result. So we can, and our output will be an integer. So we can go ahead and have an easier graph because of that. So we put our equation down so we can start working. Substitute -2 into the variable. Now we have 1/2 times -2 minus 4, and 1/2 times -2 is -1, and now we have -1 minus 4, and the result of that is -5. Plug that into the table, graph our point -2, -5, move on to the next input, which is in this case 0. So now we have 1/2 times 0 minus 4. 1/2 times 0 is 0. So now we have 0 minus 4, and 0 minus 4 is -4. Plug that into the table, graph our point 0, -4, and now we're going to go on to the last input, and that is 2 in this case. Substitute it into the equation. Now we have 1/2 times 2 minus 4, and 1/2 times 2 is 1. And now we have 1 minus 4, and the result of that is -3. So now we graph the point to -3, get rid of our work so we can focus on to the connecting the dots or the points, and we draw a line through all 3 points. And since it went through all 3 points, we know we did it correctly, and that is the equation of y is equal to 1/2 x minus 4. Now let's take a look at the last example, where we have y is equal to -2/5 x minus 3. So in this case, we're not going to have the same inputs as any of the previous examples, and some of you may have figured out what inputs we're going to choose. We're going to choose -5, 0, and 5, so that we can cancel out that fraction, and we use 5 because we look at the denominator of the fraction -2/5, and it is 5, so we want to use multiples of 5. So let's go ahead, write down the equation, and substitute the first input, which in this case is -5, and now we have -2/5 times -5 minus 3. -2/5 times -5 is 2, because when you multiply two negative numbers, they become a positive. So now we have 2 minus 3, that is -1. Put that into the table. So now we know our output, or y, and now we have the point -5, -1. So now we can go ahead, move on to the next input, in this case, which is 0. And so we substitute 0 into the equation. Now we have -2/5 times 0 minus 3. And -2/5 times 0 is 0. And now we have 0 minus 3. And the result of that is -3. Let's go ahead and plot the point. Take a look at our last input. Substitute 5 into the equation. And now we have -2/5 times 5 minus 3. And -2/5 times 5 is -2. And now we have -2 minus 3. And the result of that is -5. Let's graph our last point. And now we have 5, -5 as our last point. And once again, we're graphing 3 points so that we know when we draw our line, if it goes through all 3, we know we did it correctly. When you only do 2 points, you're not going to be sure. And with 3 points, you know for sure. So let's get rid of our work, draw our line. The line goes through all 3 points. We did it correctly, and that is the graph of equation y is equal to -2/5 x minus 3. Now it is your turn. I plug in the inputs for you already. If you want to do different inputs as well, go for it. It's just that so we can have a standard output for each of these values. And go ahead and pause the video before I show the answer in 3, 2, and 1. Here's the graph. If you got it correct, well done. If not, there's always tomorrow.